Hey guys, welcome to my new video in which I am going to tell about data science and machine learning. So let's first come to introduction of machine learning. In machine learning is evolved from the study of pattern recognition and computational learning theory in AI. Machine learning is a subset of AI in the field of computer science that often uses statistical technique to give computers the ability to learn with data without being explicitly programmed. Machine learning explores the study and construction of algorithms that can learn from and make prediction on data. Speech recognition, face recognition, antivirus, weather prediction are some of examples of machine learning. So let's have a look upon important note of machine learning. Machine learning explores the study and construction of algorithms that can learn from and make prediction on data. Closely related to computational statistics, used to devise complex model and algorithms that lend themselves to a prediction, which in a commercial use is known as predictive analytics. Classification of machine learning. Machine learning tasks are typically classified into two broad categories depending on whether there is a learning signal or feedback available to a learning system. Machine learning is basically classified into five types: supervised learning, semi-supervised learning, active learning, reinforcement learning, unsupervised learning. Supervised learning. The computer is presented with example inputs and their desired outputs given by a teacher, and the goal is to learn a general rule that maps into inputs to output as special cases. The input signal can be only partially available or restricted to spatial feedback. Semi-supervised learning. The computer is given only an incomplete training signal, a training set with some of the target output missing. Active learning. The computer can only obtain training labels for a limited set of instances based on a budget and also has to optimize its choices of object to acquire labels for. When used interactively, these can be presented to the user for labeling. Reinforcement learning. Training data is given only as feedback to the program's action in a dynamic environment, such as driving a vehicle or playing a game against an opponent. Unsupervised learning. No labels are given to the learning algorithm, leaving it on its own to find structure in its input. Unsupervised learning can be a goal in itself, discovering hidden patterns in data or a means towards an end. Application of machine learning. Another categorization of machine learning tasks arises when one considers the desired output of a machine learned system. In classification, inputs are divided into two or more classes, and the learner must produce a model that assigns unseen inputs to one or more of these classes. This is typically tackled in a supervised manner. Spam filtering is an example of classification where the inputs are email, messages, and the classes are spam and not spam. In regression, also a supervised problem, the outputs are continuous rather than discrete. In clustering, a set of input is to be divided into groups. Unlike in classification, the groups are not known beforehand, making this typically an unsupervised task. Destiny Density estimation. Find the distribution of inputs in some space. Dimensionality reduction simplifies inputs by mapping them into a lower dimensional space. Topic modeling is a related problem where a program is given a list of human language documents and is tasked with finding out which documents cover similar topics. Among other categories of machine learning problem, learning to learn its own inductive bias based on previous experience. Developmental learning, elaborated for robot learning, generates its own sequence, also called curriculum, of learning situation to cumulatively acquire repertoires of novel skills through autonomous self-exploration and social interaction with human teachers, and using guidance mechanisms such as active learning, maturation, motor synergies, and limitations. Here you can see some examples of machine learning like agriculture, automated theorem proving, adaptive website, effective computer, classifying DNA sequences, computational anatomy, marketing, and many more. Here I will give you some brief description about some of these. So first started with agriculture. Precision agriculture, satellite farming or site-specific crop management is a farming management concept based on observing, measuring, and responding to inter and intra-field variability in crops. The goal of precision agriculture research is to define a decision support system (DSS) for whole farm management with the goal of optimizing returns on inputs while preserving resources. Among these many approaches, is the phytogeomorphological approach, which ties multi-year crop growth stability characteristics to topological terrain attributes. The interest in the phytogeomorphological approach stems from the fact that geomorphology components typically dictate the hydrology of the farm field. Now, second one is brain-machine interface. A brain-computer interface, sometimes called a neural control interface, mind-machine interface, direct neural interface, or brain-machine interface, is a direct communication pathway between an enhanced or wired brain and an external device. BCI differs from neuromodulation in that it allows for bidirectional information flow. BCIs are often directed at researching, mapping, assisting, augmenting, or repairing human cognitive or sensory motor function. Third is computer network. In computer network research, network simulation is a technique whereby a software program models the behavior of a network by calculating the interaction between the different network entities, routers, switches, nodes, access point links, etc. Most simulators use discrete event simulation, the modeling of system in which state variables change at discrete point in time. The behavior of the network and various applications and services it supports can then be observed in a test lab. Various attributes of the environment can also be modified in a controlled manner to assess how the network protocols would behave under different conditions. Last application is space mapping. The space mapping methodology for modeling and design optimization of engineering systems was first discovered by John Bandler in 1993. It uses relevant existing knowledge to speed up model generation and design optimization of a system. The knowledge is updated with new validation information from the system when available. The space mapping methodology employs a quasi-global formulation that intelligently links companion, coarse, and fine models of different complexities. In engineering design, space mapping aligns a very fast coarse model with the expensive to compute fine model so as to avoid direct expensive optimization of the fine model. The alignment can be done either offline or on the fly with surrogate updates. Example, aggressive space mapping. So this is all about the application of machine learning. Now comes to approaches. These all are the approaches of machine learning. Decision tree learning, artificial neural network, inductive logic programming, deep learning, clustering, Bayesian network, sparse dictionary learning, genetic algorithm reinforcement learning, rule-based machine learning, learning classifier, feature selection approach, and so on. In my next video, I will give you some brief description about all the approaches of machine learning. Thank you for watching my video.